the switch, then you configure the network, the IP address, and then you start to configure. Sometimes you have to gain access to the switch using PuTTY, and when you gain access, it takes you into the CLI, and the CLI is in your Cisco packet tracer, and that's where you configure things. So in the real world, most times it's you do it in PuTTY. Okay, so and I decided to explain LANs, how that at the basic level of what a network is. A network is simply the connection of devices to make them communicate. So a network is basically connecting devices to communicate. So the goal is to ensure communication. All right. So now you can achieve that kind of communication even without an internet access. Yeah. So I said that in the last class that you can achieve a LAN that doesn't have an internet access. All you need to do is have a switch, have some devices, and you connect them. You have a local server, and I used an example of my room. So in my room right now, there's a printer in my room. There are two laptops. There's a MacBook and there's a Dell lap laptop here. So I can and then there's an MTN 5G router. So yeah, in this room right now, I can create a LAN. All I need to do is get an Ethernet cable, um, or get a USB cable, connect connect the Ethernet RJ45 cable to my laptop's port, and then connect it to the 5G router, and that 5G router can give me internet access. But let's say I don't even have that. Okay, so let us say that um, I want to be able to share files between the Dell laptop and the MacBook, and I want to be able to print. So I can form a LAN, right? All I need to do is get a cable to connect both laptops, and then I can connect to the printer through another cable. Let's say maybe a USB. If the printer supports USB. So by virtue of the connection between both laptops, I can share files. I can send a file from my Dell to the MacBook. I can send a file to the printer. So um, I have formed a network. Why have I formed a network? Simply because they can all communicate, right? So the goal is to ensure communication. So, but when you want to communicate with a device that is not in your LAN, all right, you need to use um, more advanced network devices. That's where switches come in, routers come in. So um, if IP addressing comes in, so that's because you are trying to reach a device that is not in your LAN. So I said that the internet is the interconnection of different LANs and WANs. Okay, so a LAN is a local area network. A WAN is a wide area network. So that's a summary of all that has been said so far. But um, there was more that was said, but that's just a summary. So we designed this topology just to show like a form of land, and we did a simulation in Cisco Packet Tracer of how the packets moved, and then when I tried to ping an IP address that was not in the LAN, it was not able to successfully deliver until we used the router. So we all that we've done so far is to show the essentiality of networking, to show the to explain networking from a basic concept, all right? And we built a simple LAN. Now we are taking it to level, and we decided to build a network topology. So for everyone that was around yesterday, it was a very interesting class. I can I can tell you for free that it was very fun and very interesting. So I performed a magic yesterday night before we ended the meeting, and I think I want to perform that magic again. So the magic was to connect this finance laptop one to this access point. So let me quickly explain this network topology for those that are just joining for the first time. So we're trying to create a network topology that depicts how it is in an enterprise network. So an enterprise network is like a large organization's network. So a company, for example, like Deloitte, you know, that's like an enterprise. The And I said yesterday that before you even before you even um, before you configure devices, you need to first understand the network requirements, right? You need to you need to understand that first before you design a network. You need to understand the requirements. You need to know the devices you need. You need to ensure that there are certain principles that must be followed in the network design. So some of those principles include that a network must be redundant, a network must be scalable, it must be scalable, it must be there must be security, it must be secured, and there must be QoS. I talked about QoS yesterday, and QoS is quality of service. It's an advanced concept in networking. There's there's literally an 8-hour video on YouTube just on QoS. So I said many things yesterday, many interesting things, right? So, um, but let's go into today's meeting. So this is an enterprise network, and we had we created different departments: HR, finance, marketing, developers, cybersecurity engineers, cybersecurity engineers, management, legal team, accounting, content, and you know. So those typified different departments in an enterprise such as Deloitte, and so we decided to simulate a network between two branches of the same company. Don't forget that at the basic level, networking is simply configuring devices devices in such a way that they can communicate and they can share resources, right? So this is a company that has two branches, one in Lagos, one in Abuja, and they want to ensure that the Lagos branch can communicate with the Abuja branch. You can't see my screen. Can we see my screen? It must be your network. Yeah. So Lagos branch wants to communicate with Abuja branch. So because it is a large organization, the devices that will be involved might be more than my room's LAN, right? But the principle remains the same. We're just trying to configure devices in such a way that they can communicate with each other. Okay, so we decided to give two devices to each department, because we can't we can't show everything, right? HR's HR department now can have 15 employees, so we can't simulate that in Cisco Packet Tracer that much. It will be so much for us to do that. So we try to just use two devices from each department. So this is HR, with finance. So we got a switch. Now, if you check on Google, the price of a switch is quite expensive. So um, if you do the Cisco 9300 switch price is I think it's even end of life. So okay, it's not end of life. So the price is $6,566. So if you convert it to naira, in fact, there's even a discount sef. So if you convert it to naira, that's how much. That's 10 million. So this small switch you see here is like 10M. So it is very expensive to build a network in an enterprise level. It's quite expensive. So usually we would ensure that the network is redundant, right? So we want to ensure that there's no single point of failure. Um, so that's why we got another switch. Spent 20 million just on these two switches, right? So and so in network design, there are two types of models. I explained that yesterday. There's the collapsed core design and there's a three-tier hierarchical design. So in the three-tier hierarchical design, you must have access layer, distribution layer, and core layer. So the access layer talks about it's basically is the layer that corresponds to the endpoints, the hosts that are connected to the switch. So for example, these laptops, these PCs, they are in the access layer. So this switch is an access switch, right? There are three kinds of switches: access switches, distribution switches, and core switches. In a enterprise network, the access switch is usually a layer 2 switch. The distribution switch is usually a layer 3 switch, and the core switch is usually a layer 3 switch also. So that's why we're using a layer 2 switch. So this is still the access layer. So One device that organizations will usually use is an access point. Okay, I explained what an access point is yesterday. That an access point helps you extend a network. It's like a bridge between a wireless wireless devices and the wired network. So an access point helps you connect wireless devices to a wired network, right? So this switch, you would usually connect to the switch with Ethernet cables, right? But what if there are people in Deloitte that have a phone and they want to still connect to the LAN? How are we going to achieve that? We need to use an access point. An access point helps you connect devices that would not be able to use the an Ethernet cable. It allows you connect them to the LAN. So laptops, they have Wi-Fi, right? So we can wirelessly connect to the switch through the access point. So the access point is connected. So I showed a picture yesterday of an access point. So um, Cisco access point. So let's first check the price. Um, so like 280k. Okay. So let's see pictures. So I showed us a picture yesterday. So this one is 2M. So it will have an RJ45 ports that you can connect to. So this is an access point, right? So it will have a LAN port, the RJ45 port that you can connect to see it. So you use the cable, you plug it into it, and then you plug it to the switch. And that's what we did here. We used our cable, we plug it to the access point, and then we plug it to the switch. So the access point is plugged to the switch. Then I configured the access point. I configured port one. I gave a password, Nene Ojidan, and I configured it to be WPA2. This is a wireless protocol, and it's 2.4 gigahertz. There's 5 gigahertz. In fact, there's 6 gigahertz. I think so. I think so. Let me confirm so I don't misinform. So yes, there's wireless 6 gigahertz. So there's 5 gigahertz, there's 2.4, there's 6. So I configured this access point. I give it a password and I connected, you know, to the access point with my laptop, and people wanted to know how I did it. So I did it yesterday, but they did not get it. So let me do it again. So these modules are they give your laptop functionalities, certain functionalities. They are like ports that you can add to your laptop. So this WPC, when you click on it, you can click on so this NM1CE means that it's a single Ethernet port that can connect a LAN. Okay, so if you check this is a gigabit Ethernet module. This is a gigabit, so you can, if you want to use a cable that supports gigabit Ethernet speed, you can use this module and add it to the laptop. So I put the laptop off, right? Then I remove this module And because we want to do wireless, we need to look for the wireless module. So WPC is the wireless module, 2.4 gigahertz wireless interface, suitable for wireless connection. So I'm going to add it here, right, and then put it on. So once I put it on, it won't see the point immediately. So I have to go to desktop, I have to go to PC wireless, and I have to click on connect here. You click on connect here, then it will see the access point. So I named it as default. That's the name. So you click on connect. It will ask you for password. Our password is Nene OG Dan DAN. Not a good password, but it is what it is. So that it has connected, right? So typically, the wireless devices can connect to the access point. Let's now give them IP addresses, right? So we've decided to configure the Lagos branch with 10.0. So let's give each of them IP addresses. So 192.168.10. Let's use dot two. I'm going to use our gateway as 192.16. I already explained what a gateway is, right? Do we still remember what I explained? Anyone on the call? Do we still remember? Anyone on the call that remembers what I explained as the gateway? Dan, Daniel, Nene. Why is Nene giving me? Yeah, do you remember what I said about the gateway?
Yes, I can. Yes, I remember.
Okay, so what did I say it is?
Is you said it's like the door to other network.
Okay, okay, that's, no, I can manage that. That's that's the idea. The gateway i- the gateway represents an interface of a device can that you forward packets to when the destination you are trying to reach is not in the LAN. So if you're trying to reach the 20.0 network, we have to configure a gateway that can take that packet to that network. If we don't have a gateway, we will not be able to reach other lands. Is it clear?
Yes.
Okay, someone is trying to join. How did Katara get this link? It's okay. It's okay. Okay. So um let us so this is 10.1, right? So this is 10.1. So we'll still configure VLANs. Let's just take it one. This 10.2. Just take it one step at a time. So this 10.2. This is should be 10.3. This should be 10.4. So 2, 3, 4. So just 192.168.10.3, and subnet marks will be the gateway will be 10.1, right? Let's configure this. Four. One. So finance will use 5, gateway 1. So let us see. Let's see something in action. So we have given 4 of these devices IP address. So let's see how topology is holding up so far. So let's go to simulation mode and let's try to ping from here. Let's see how the network traffic will go. Ping 192.168.10.2. So it comes here, right? Goes to the access point. Access point should forward it to the switch. Yeah, the switch should forward it to everybody. So only HR laptop 1 would send a response, right? And then to take it back to the access point, I'm going to take it back to finance LP2. Move now.
You want this one?
So I need to explain what's happened. Yeah, so finance LP2 got it. So I need to explain what happened. So you are seeing you are seeing that our network is beginning to make sense, right? So our access point is doing what it should do. It's connecting wireless devices to the switch. You see that when the packet left laptop 2 to the access point sent it to the switch. So let's see if we can reset the simulation. So it goes to the access point. Yeah, access point takes it to the switch. So gets the switch. The switch floods. Now I explained something about switches in one of our classes, that switches, layer 2 switches do 3 major things. They learn, they flood, they forward, depending on their MAC address table. I ran a command on this switch in the first class. Um, I ran a command. I think it was show MAC address address. Am I spelling address right? Table. So depending on show running config. Okay, so let's enter. We're in simulation mode. So depending on the switch's MAC address table, a switch will learn forward or flood. I already explained these things, but let me try and explain it again in case we forgot. When a switch gets a packet for the first time, you just bought a brand new switch, so there's nothing in the MAC address table. So when a switch gets a packet for the first time, it does not know what to do with it. It learns the MAC address of the sender, right? It populates its MAC address table. A switch is very intelligent. It will learn the MAC address of the sender and fill it in its MAC address table, and then it will broadcast the message. Okay, so um, which knows that this marketing PC1, this marketing PC1, it knows the interface it is connected to on the switch, and then it will know that, oh, PC1 with XYZ MAC address. That's why I wrote MAC addresses out here, because I explained it. So it will say that, oh, on my interface XYZ, oh, this marketing PC is connected to me. So it knows that by virtue of the MAC address. Why? Because MAC addresses are unique to every device. Okay, so the switch learns that layer 2 information, and then it sends it floods, because it does not know the MAC address of the destination IP address we're trying to reach. It does not know the MAC address, so it will flood it. It will flood the packet to know who has that MAC address. When it floods it, it is expected that only the device that has the destination MAC address would respond, right? So you see that only one of them should respond. Let's reset. Let me try and ping it. But I think the switch has already learnt that it might have already learnt the MAC addresses. So I'm not sure. Let's see. So you go to the access point, go to the switch. Now the switch is sending it directly because it has learnt. So I can't show us that process again now, because the switch has learnt the MAC address, so it does not flood all the devices again. So once a switch learns the MAC address, it does not flood, it forwards, because it already knows that, oh, on my interface, on my fast internet 0/2 interface, this particular device that has MAC address is connected to me, so I will forward it directly to it. So the laptop responds back to the switch will send it to the access point, and the access point will check it and forward it to both devices that are connected to it. Now, it is trying to learn and then to forward it again, and then this time this knows, this accepts the packet. So we can did we get that? Hope it was not strange. Did we get that?
Yeah.
Are we is anyone lost? Let me be sure. 15 minutes more. My battery is almost dead.
Go
So
on.
is okay. My battery is almost dead though, but let's see. Um
You no get light.
they took the lights this evening using
Lucky
my
for
laptop.
them lucky where you dey. No dey get light. Lucky na temu lucky.
Oh God, God, I beg. Alima, you raised your hand.
Mr. Victor.
Yeah, you said you wanted to show us the forwarding process again, but then because the speaker learned the MAC address of that device, it's not
Yeah.
going to flow. Yeah,
Yeah.
but can you try sending another device? Will you not
Okay.
to show us?
Yeah. Let me configure another device.
Oh, okay.
So let's give this 10.7. So the switch hasn't lent. So now the switch hasn't lent marketing PCs MAC address, right? So let's go back to simulation mode and let's ping marketing PC 10.7. So click play. It floods again, right? So only marketing PC is not showing cancel. So marketing PC will respond. You see, it responds, right? And then switch forwards again. So now when the finance sends another packet, because a ping, when you send a ping, it continues to send until you stop. So when the PC sends another one, the switch will not forward. It will not flood, it will forward. Yeah, it will forward now because it has learned marketing PC's address. Alima, is it clear now?
Yes, it's clear. It's clear.
Yeah. So that's how switches work. That's how. So they learn, they forward, and they flood depending on the information in their MAC address table. So I think I want to stop here tonight. Um, yeah, let me just stop here tonight so that we don't start doing something and then my laptop goes off. So, oh, are we getting something? Are we enjoying
Yeah, I'm enjoying it though.
it? Hey, Nene, did you catch it?
Yes, thank you.
Yeah. So we're going to still configure these devices, and we're going to also still configure for Abuja branch, and we're going to configure VLANs. We're going to enable spanning tree protocol, That's a layer 2 redundancy protocol. We're gonna do a lot of fun stuff. If I do show running config, you're gonna see something called PVST. So this spanning tree mode, PVST. This protocol is very, very important. I'm going to try my best to explain it as we dig deep into this topology, right? So, any question for my laptop dies? Any question? Any question? Any question so far?
This okay. I think maybe in next class you will explain more on that one.
What's that?
Is on this protocol, this planetary protocol. So I feel like if you explain more on that, maybe the next class.
Okay, no problem. It's a very, very. I don't want us to start doing the complex things, but I'm coming. Nene Oji.
Do you know? Well, let me tell you something.
Yeah.
This Nene you're calling now. If you call that Nene, it feels like you're here or something like that. Because my sister's name is Nene. You get it. So when you now say
Oh,
Nene,
okay.
and you mention my son name, I feel like something is wrong.
Oh my God. Alima, you have a question. Oh my God.
Yes, the previous network topology showed us the network design, that simple LAN network.
Yeah.
Yeah, so you're showing us connection between the admin laptop and the console port. And you said it's a normal RJ45 cable
Yeah.
that is being used. But in this cable I'm seeing like, okay, from what I know, an RJ45 cable is similar to this copper straight through cable you use on Cisco packet, right?
Something like that.
Okay. So like I'm wondering why the cable
You're wondering what?
why the cable is different. It looks like a different cable.
Yeah, it's a console. It's a console. It's a console. So see, a console cable often uses an RJ45 connector on one end. So
So it's different from an Ethernet cable.
so okay, you were not in the class where I talked about Ethernet cables. I already taught on Ethernet cables, right? And I explained how there are different kinds of cables. There are fiber optic cables, and um, they use an SFP port. Fiber optic cables use an SFP port. There's an SFP connector, single form pluggable. So Ethernet cables usually would have an RJ45 mount. Most Ethernet cables. So if I search on most Ethernet cables, whether straight through or crossover, use an RJ45 connector, right? Yes. So a console, the difference is not in the mouth of the cable per se. For example, Ethernet cables have been built to function by carrying electric signals, right? But fiber optic cables don't use they don't function based on electrical signals. They function based on light waves. My laptop is low, so um, I think I'm going to do a refresher on Ethernet cables in the next class. I think that would I will take time to explain more. Right? Would that be fine? My laptop is almost dead.
Yeah, that's fine.
Okay. So good night, everyone.
Good
Daniel,
night.
I'm expecting the YouTube link.
Me and the first something. Wow, Mona, give me something.
What's that?
This thing I thought. But I'll see, yeah.
Mm,
Okay, so I'm working on that stuff. Oh, hope it's not. This will not be that meeting now. That meeting is.
mm.
When I still the same meeting now. See, I'm working on that stuff now. So we're looking at only the issue should, sorry, the solution should come from only networking, right?
You can add others too.
Okay.
Yeah.
If you add others, I'll like, can we be able to simulate
Just
that?
just add them. We would decide that when we have the meeting.
Okay.
Yeah.
Okay. So to relay this